All right, so we are starting Unit 4, and this lesson is kind of new, but at the same time, kind of not, um, because really we've worked through all these different types of function already, and so really what's happening is we're reviewing everything we've done so far to kind of set us up for future concepts. Um, and I think what I'm doing, because obviously in class I did it a little bit differently, what I'm going to do is just going to kind of go through and talk about a little bit of each of these graphs and how they're different and so on and so forth. So the first one that we have here, a characteristic is that there is an endpoint here. This is our radical function. Now radical, this is a general equation where you have y is equal to the nth root of x, right? So that's in general, again, this is the x squared function, or I'm sorry, the square root of x function. Another one that we've seen is y is equal to the cube root of x. Now that's gonna look a little bit different because there is the negatives that's allowed in these cube root of x, but you just notice that this section looks very, very similar. So we did this like back in like quarter 1 or quarter 2 or something like that. This one's a little bit harder. I'm going to come back to this probably, but this is our polynomial function. And I say that it's a little bit harder because the polynomial can really take a lot of different forms, a lot of shapes. This one just happens to be a one with an even power. If you remember that we talked about this a long, long, long time ago. Actually, not even that long ago now that I think about it. It's probably just a couple months ago, right? We talked about, okay, like this side and this side, the end behavior are both pointing to positive infinity. Therefore, I know, and they're both pointing upwards. So therefore, I know this must be an even, positive even power function. So it's probably something like y is equal to x to the sixth or something like that. We don't know exactly what it is, but it's something along those lines. And we can see that there's 1, 2, 3, 4 roots, right? So again, it's probably x to the sixth, x to the fourth, or something along those lines, where we can have this kind of function. Okay, but the big characteristics that we have seen is that it is continuous. It is for all real numbers for my x, and you can see that it does go on forever on the left hand side and right hand side, and it has all the points in between as well. So it is continuous, unlike my radical, where it has an endpoint. So that means for this particular graph, my domain is from 0 to positive infinity, but it does not have any of the negatives here. Um, this is more familiar, I hope, but this is my quadratic function. Quadratic function, and this is my y is equal to x squared, right? Or I guess in general, I guess the one they have is ax squared plus bx plus c. Right, this is my quadratic function with my parabola. That one should be pretty straightforward. This one does have an asymptote going across. It is not drawn for us, but it does have an asymptote. This is my exponential function, where the equation is y is equal to a times b dx. And we're going to go over all these again at the end, I think, as a summary for parent functions. These are just general, hopefully general shapes. Here, I do have 2 asymptotes, right? So this is what we actually worked on pretty recently. I think the unit before my trig. These are my rational functions where I have y is equal to 1 over x. It's also possible to have 1 over x squared, but the equation looks just a little bit different like so, or the graph. Okay, and this should be very, very familiar to all of us. This is our linear function, which is a type of a polynomial function, which is also, again, why I said, like, polynomials are kind of tricky because, mx plus b, because there are so many types. Because also the quadratic is also a polynomial function, actually, but because it's used so often, we really just talk about it as a quadratic equation. Now, this one is actually a new one. But you've probably seen it before. This is actually called my absolute value. Absolute value function, where the equation is y is equal to absolute value of x, like so. And this one is our inverse exponential equation. This is our logarithmic function, where the general form is y is equal to log of x. The other form that we have is the natural log. So we have seen a little bit of this as well. And so I hope this is pretty clear. And the last one, of course, we just went through this. These are my trigonometric equation. Now, specifically, this one's sine, but we do have sine and cosine. In fact, I don't know why this is only bx. We did a sine bx plus c, or y is equal to a cosine of bx plus c. All right, so there are multiple forms that we've worked with before. So that's kind of like a general, like, okay, what's the function type, like the name of it, what's the general equation, what it looks like normally, and as well as the graph, what it looks like as well. I'm going to focus a little bit more on the equation and the name, just so we have that one-to-one, like we understand what is what. Let's take a look at the linears first. Well, I only have one example here, but you'll notice that it does come in the form of mx plus b. This is my this is linear, and although I've color-coded just to kind of show once again, but you'll see that this is in the form that y is equal to mx plus b. Okay, now we do have, I'm going to go through one by one. Let's go down to exponentials. And now exponentials, they have the variable is in the exponent. So I hope that kind of helps you to recognize what an exponential function looks like. You'll notice that I have two here because both of them, my x, my variable, is in the exponent of my functions right here, right? It's an exponent. Exponent. All right, so exponential, where the x is in the exponent. Right, exponent. Okay, now the next one that we have is a quadratic. I don't think there's a quadratic on here, actually. Now let me look at it. No, yeah, there's no quadratic. Let's go on. Let's skip polynomial for now. I want to go to rational first. Now, I hope this helps you remember, but a rational equation, remember the word rational? Rational means fraction, or it can be written as a fraction, right? So rational means fraction, essentially. Meaning my x is in a fraction, or in the denominator specifically. Okay, so I have two here. They're both rational, and they are fractions. 1 over x. 1 over x squared. Okay, and again, I think a lot of people do get confused because we see x squared and we get kind of scared, or we see even just the fact that it's an x is like a variable. But remember that x is supposed to stand for some number, right? So if you have if x is equal to 5, you have 1 over 5. That's a fraction, right? So don't be scared of that. It's just a fraction. Okay, absolute value, I think it is the newest one that we have. But at the same time, as long as you see the notation with the 2 bars, right, that is an absolute value. That's an absolute value function. So I don't want you to get caught up on the name or anything. It is the absolute value. Now, absolute value just simply means how far away am I from 0? Or usually to make it simpler, we just think about it as the positive version. So we aren't going to go into detail about what the absolute value function is or does, but that's why you have this V shape for the absolute value, because it only takes the positive value. So for example, -5, let's say this is -5. You put in x as -5. The absolute value function says -5 is 5 away from 0. So it goes up to +5. Or you can say that it takes the positive version of it. Again, we do have our logarithmic graph here. Our logarithmic graph does have the word either log or natural log in the function itself. So this one will have the natural log in there. I don't know why I didn't highlight it. This has the natural log in there. So therefore, this one is a logarithmic function. Logarithmic function. Our trigonometric should be fairly straightforward. Again, our trigonometry, right? That's our sine, our cosine, our tangent. We haven't talked about secant or cosecant or cotangent, but I mean, you will talk about it next year, so might as well hear about it anyway, right? But those are the trig functions that we know, right? That's my cosine, trigonometric. Same thing here. I have sine, trigonometric, right? So those should be pretty straightforward. We've worked with those a lot. Finally, not finally, but our radical are going to be these two. And the reason for that is, so I don't know, I'm pretty sure we talked about this before, but the square root symbol, that's called a radical. That's called a radical. Regardless of what the power is, we call that the radical. So this guy right here, that's a radical. This guy right here, that's a radical. So we do have a pretty clear way to see radical functions. Okay, if we have that little house-looking thing, right? That's a radical function. Now, the last one that we did not talk about here, obviously, this is going to be our polynomial. That's our last one standing here. It is polynomial. Now, poly, for some of y'all, you might know that the polynomial, the word poly means many or multiple, right? And so polynomial just simply means that there are basically like there's a lot of terms, right? Because you see I have 1, 2, 3, 4. And even if I have only like x squared minus 2, even though that's only 2 terms, technically the a value for x is 0. We can think about it like, let's say if you have like x to the 7th minus 1, it's like, oh, well, there's only 2 terms. Why is it a polynomial? Well, technically it's x to the 7th plus 0, x to the 6th plus 0, x to the 5th, and da 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 da, which is why it's still technically like there's many, many terms. It just so happens a lot of those terms go to 0. Okay, so therefore, even though I may have gone back too many times, I hope I didn't just crash. Okay, we're okay, I think. Okay, I think it just went back slightly too. Oh, yep, I clicked it way too many times. All right, I think we're okay. Okay, yep, all right, we're okay. Okay, but x to the 7th, again, right? That just simply means x to the 7th plus all these different terms. I'm going to erase this just not to confuse anybody here. But that's what it means. That's why we can say this is a polynomial, or even, sorry, x to the 7th plus 1 could just be, it's still called polynomial, despite the fact that it looks like it only has 2 terms. Okay, so kind of just, again, kind of run through these again. Again, linear, we have the form of mx plus b. For quadratic, you're really looking for y is equal to x squared, right? Whatever other terms there might be, we call that x squared. For cubic, it's not on here, but cubic is x cubed to the 3rd power. Exponential, you have the word exponent again, so your x is in the exponents. For a rational, right, we're looking for fractions, so 1 over x squared. Absolute value, we're looking for the bars. Logarithmic, we're looking for the word log or natural log. Trigonometric, that's sine, cosine, tangent. Radical, we're looking for the radical. And finally, polynomial is whatever's left over. But again, generally speaking, it's x to some power. So again, linear, quadratic, cubic, all kind of fall into the polynomials. Okay, now let's take a look at the graph once again. So for this one, we do see that this guy does start at a maximum. So that does indicate to me that not only is this trigonometric because of the wave, but it is a cosine graph. Because we did this before, so I'm not talking too much about this. We literally just finished graphing and stuff for trig functions, so I'm not too worried. This one you do have to be a little bit careful of. For B, there is an endpoint. Once again, this is going to be a radical equation. So for B, it is my now, is it this one or this one? Well, because there is an endpoint, it's actually going to be the square root, because square roots, you can't have negative values. Okay, we did that a while back. This one, you do see a dotted line, meaning our asymptote, which tells me that it is going to, and because it's vertical, I know it's going to be a logarithmic function. This is my natural log. Okay, so if you have a vertical asymptote, you should have a log function. And if you take a look at this one, we do have 2 asymptotes. I have a vertical one, kind of like my log, but I also have a horizontal one. This is an characteristic of my rational function. And specifically, this is the parent function for 1 over x. Linear, we're very, very familiar with that, so I'm not going to talk too much about that. That's our only one with a straight line. And again, I'm going to jump down to g for a second. This is going to be my absolute value, right? This is the one, again, with the v. If you see a v, that's going to be my absolute value function. Let's go about f real quick because there is something here that is not drawn for you, but this does have a horizontal asymptote. The horizontal asymptote is an indicator to me that it is going to be a exponential function, but it's also going up, right? It's getting small from small to big. That is a exponential growth. Last but not least, this last one here. This is actually also my radical, but this is a cube root. That's why it looks like the way that it does. So it almost looks like the right-hand side, right? If you take only this part, it looks kind of like the square root. Okay, so hopefully that hopefully helps somebody there. I'm going to first jump to J because I do have another wave, and this time I'm starting at the 0. So that does mean, or I'm sorry, the midline. So that is a sine function that I have. This one is a little bit not as clear, or I mean, it's not clear again, but it does have that horizontal asymptote. A horizontal asymptote does mean an exponential equation, but again, because it's decreasing, this is exponential decay. And we're going to look at that one also in terms of a parent function. K does have a vertical as well as a horizontal asymptote, so this is a rational function once again. But since they're both in the top side of my my graph, the positive y's, I know that this is 1 over x squared. And last but not least, with the bends that it has, we do have a polynomial equation here. And specifically, we can also look at the end behavior to really confirm that. You see that on the left-hand side, it's going to positive infinity. On the right, it's going to negative infinity. So I know that it's an odd power, but not only that, I know that because as x goes to negative infinity, it's going to positive infinity, and the opposite for x goes to positive infinity, I know it has a negative coefficient. So that is going to match up nicely there. So let's go ahead and wrap up this video with a parent function for all the graphs. A linear function, once again, that is basically y is equal to x. Very straightforward. I just have a diagonal line. Usually looks like that. Very straightforward. Quadratic, I do have y is equal to x squared. We've seen these many, many times before. This is where my graph no longer is a straight line, but rather it's a parabola. Again, we've worked with these quite a bit. So I think that should be pretty straightforward. Cubic is the next one in line, x cubed, right? Since it is third power. And again, I have these few points that I can work with, but this time, just kind of like the quadratic, it's going to increase and decrease very, very quickly. I'm not going to even really be able to draw more than 3 points there. Square root is y is equal to the square root of x. Surprise, surprise. I have these 3 points that I can draw, because I can just take the square root of each of those to get nice whole numbers. Didn't quite get it there. Ugh, I hate drawing on using the XP pen. All right, good enough. And the cube root is, well, surprise again, the cube root looks like this. And it will have the same 3 points as my x cubed, but it's going to be a lot flatter. It's going to be a lot flatter, so it looks something like this. Rational, again, there are 2. I have y equals 1 over x. Again, I do have a vertical asymptote as well as a horizontal asymptote. And I have these points. I don't know if you remember these points. If not, I do recommend you rewatch those videos from a long time ago. But at the same time, like you don't really need to know exactly how to get these points. You need to, I would just say you need to know the general shapes. And I'm going to just kind of sketch out 1 over x squared. 1 over x squared is going to look something like this. Again, all I care about is the general shapes that you should know to recognize them. Logarithmic will have a vertical asymptote. I'm going to go through this point right here once again. And because for 1 over log of x as well as 1 over, I'm sorry, y is equal to log of x as well as y is equal to natural log, they look basically the same. I'm not going to draw two different ones. They both basically look like this graph. And exponential is the inverse for log. And so this one has a horizontal asymptote. And for growth, it's going to look like this, where I'm hugging the asymptote, go through my point. I'm going to increase very quickly here, like so. Now, both of my growth and my decay will look the same, but the big difference is my b must be greater than 1 for growth, and for decay, it still has a horizontal asymptote. But b in this case must be greater than 0, but less than 1 to get decay. So that's the big difference. Okay, so really, like I said, we've done all these before. In the very beginning of the year, I think we started off with the exponential. We start with exponential. We went to logarithmic. We looked at a little bit of cube root as well as a square root. Then we went on to talk about the quadratic form of quadratic equations. And then we jumped to rationals, then trig. And so it's really every single one that we've done this year. We will be looking at all these and looking at the different transformations for the next class. But for now, it's just a review of everything we did. Thank you for watching this video. I hope that makes sense. Please let me know if you have any questions.